Okay, so it's 2 o'clock. I guess it's show time, and we'll kick this off. So today we're going to talk about noise barriers, QuietSlide, and quiet lift sound control doors. I always like to start these with our literature up front, so you can see that we've developed new literature for your use. That's what it looks like. So we'll have a prompt later on in the presentation to tell you where you can get the literature if you need some. So good afternoon. I'd like to thank you for joining this webinar concerning the QuietSlide horizontal and vertical lift doors. My name is Steve Mitchell. I'm the founder of Noise Barriers, and I'm going to be your host for this presentation, and I hope you'll find it informative. The purpose of the webinar is to introduce you to the many variations of horizontal sliding and vertical lifting sound control doors offered by Noise Barriers. So, why should you consider a noise barrier sliding door? Well, we offer multiple door designs, STC ratings, and we've developed a fast and safe installation method, and we're going to be sharing that with you in this presentation. We've got our own in-house design capability, and we couple this with PE services that are familiar with our product, and this allows us to not only design these one-off door solutions, but we can also accurately and quickly bid projects and then prepare submittals and shop releases at a minimal cost and in a timely manner. We've got the capability to quickly assist any consultant, architect, construction manager, owner, end user on any size door project anywhere in the country. We do build mock-ups of all of these one-off special door designs. I'm going to show you a lot of pictures to get started that just shows you the variety of what we do. Whenever possible, we do build a mock-up and test that door in-house for operation before we send it. Some are too large to do that too, but in those cases, we do set up the control system, the guide rail block system, the drive belt system before shipping it. And you're going to see that we offer multiple door designs, SC3 ratings, and we'll show you how we do this fast installations capability. Now, when we get involved in these types of projects, our scope is the horizontal sliding or vertical lift door, including the control system, all PE calculations if necessary, supply of the door system, the control panel, and we provide installation services. So we do provide you with a total turnkey capability. And we can design and supply an acoustic horizontal or vertical lift door to meet the most unusual and rigorous applications, and you're going to see some of those shortly. These sliding door products are called QuietSlide and QuietLift. So let's talk about sliding doors. We provide horizontal, motorized or manually operated that can either slide to the right, slide to the left. They can be biparting, they can be bifolding, they can be L-shaped, whatever the project calls for. On vertical lift doors, these are only going to be motorized. They're just, it takes too long to use like a chain fall to hoist these up. So these are always motorized with a chain fall backup so that if there's a problem with the motor, you can still open the door. So we do these two ways. We either do a single slab or we do a telescoping door. You'll see examples of this. It all depends on the headroom available as to whether it would be a single slab or a telescoping door. Typical uses for these horizontal sliding doors and the vertical lift doors, we see a lot of them on theaters and performing arts centers and sound stages, both professional and educational facilities. We use these in all types of test cells for engines, vehicles, any noise generating products. If they're large, they often require a big sliding door. We can provide these for either interior or exterior applications. We actually have some that we provided in Florida. They don't meet the Dade County requirement. We do meet it for hurricane winds, but not for impact. But we can design these for hurricane type wind forces for exterior applications. We see these a lot in manufacturing process areas where somebody wants to block off areas within a facility, yet need a large opening. Another typical application are large genset enclosures or mechanical rooms or compressor rooms. So this would be a typical sliding door. This happens to be a 16-foot by 16-foot door. We provided 6 of these to Pinewood Studios down in the Dominican Republic. And this is our old design. You can see up here on the left, the large vertical red tower is the storage pocket, leading edge pocket. So the door is going to slide to the left, and this uses a chain drive mechanism. And you'll see that we've changed that, but I want you to see this particular door, and you're going to see it operate. Now, we had to speed this up, so the doors don't really open this fast, but you'll notice at the bottom of the door, as it opens, it lifts. So you see, as soon as the door starts to open, it lifts up. Now, we had to build doors like that when we first started doing sliding doors, because we didn't have a system with the track and trolley that would allow us to slide a door against a smooth, flat finish. We changed that. These are some 13-foot wide by 32-foot high manually sliding panels. These move actually quite easily. This is just to separate a stage area from a gymnasium. So depending on the use of the room, the sliding panels will be slid over to the right, out of the way, if they're going to have people up on the stage, or if they're just playing a basketball game or volleyball or something, they'll close it up. What I'm doing right now to get started is to show you some of the variety of these doors that we provide. These are a couple of bypassing sliding doors. There's 4 doors here altogether, 2 that you see, and then 2 at the other end of this enclosure. This enclosure is about 95 feet long. This is for Caterpillar, where they build a type of combine, and they have 2 production lines. So either production line can run, and they can move a product in and out of this by sliding the door to the right or the door to the left. This would be a typical stage door. This is the College of DePaul University School of Music in Chicago. Again, this is one of our older designs where the door actually lifts. Now, if this particular door, if it were manually operated, we need to have a little bit of lift there because it'd be too difficult to slide the door along the floor. These are some large biparting sliding doors at some test cells at a Cummins facility in Texas. We've actually done these in South Africa, Singapore, Mongolia, Russia, a couple of other countries. So we can deal with these internationally, whatever the electrical requirements are. This is a large biparting sliding door we did for a Boeing facility. Behind this wall is where they actually build the wings for the fighter aircraft for the Air Force and Navy. And they wanted to partition that off from the rest of the facility. These doors bipart, and they challenged this. They wanted to know if we could set up the controls so they could only open up the left side or just the right side, or if they could open them up just part way. And we were able to accomplish all that. Our design engineer on this is Mike Dott, and he just does a terrific job on these controls. This would be a biparting door with a slot in the roof of the production cell, because it's a Caterpillar thermal spray facility. So they'll use a chain hoist and come down from a crane overhead, and they can lift parts through this door and set it on this silver production table. When we talk about an L-shaped door, this is what we're looking at. This is a door that's 8 feet wide, 10 feet tall, and it's 10 feet deep into this enclosure. On the photo on the left, you see where the big black window is. It's a weld screen that is protecting a worker's eyes from the thermal spray process. When they want to move a part in, they use the overhead crane. You can see the yellow rail in the background on the right side, and they're able to lift parts directly through this opening. Now, here's where we started going to a different type of control system and drive system. You can see the threshold across the floor. This gives us a nice, flat, smooth surface for the door to slide against, so the door doesn't need to lift. That's on the right side. It's very low. It's a 1/4 of an inch with a beveled front, so it's not a trip hazard. A cart with small wheels can easily roll over that. This is a 50-foot by 25 or 24-foot high, what's called a telescoping door. In this particular door, when it's opened, it sits down on the floor in front of the wall that we built. You can see the panels right behind the yellow guardrail. So when this client, this is at Fairbanks Morse in Beloit, Wisconsin, they build large shipboard engines. Engines can be over 40 feet long. And they use this wall with this door in it to shield the production area from the open doors of the shipping area. So the production's on this the one side. You can see where the white opening is. That's railroad cars are backed in there, and they use this door. They'll lower it and they'll lift the engine over and set it on a flatbed rail car. What's interesting about this is we had to do this with no header across the top. So these are two independent towers, and the doors ride up and down on two separate motors that are synchronized together. We built each of these 50-foot by 12-foot slabs in our shop, so when they went out to be installed, they just brought them in on a rail car or a flatbed truck, used this overhead crane and lifted them right off the vehicle and dropped them into place. Made for a safe and easy installation. This is just another view of it during the installation phase. Again, you can see the tower here. On the left, you see an opening for a small double-leaf door. That's to the left of the sliding door. And then there's the control tower that guides the door up and down. And in that are counterweights. This is one of the very first vertical lift doors we did. This happens to be 34 feet by 32 foot high. This is into a planar coax test room at Waukesha Electric where they test transformers. So I'm going to show you, now this is a very quick video, it's loud. The doors obviously do not lift and close as quickly, but we wanted to be able to share this video with you. This actually is several minutes long if we hadn't shortened it. So thanks to Amy, we've got this thing where we can see it quickly. Again, a little bit loud. So let me. So you see what happens there is the first leaf, the bottom leaf, starts to lift up. As it gets up adjacent to the center leaf, it connects with that, and the two lift up, and then when we get up to the top one, it lifts that up. So we end up with the full 32 foot height. So just one more time. You see, here we're going. It's all our time to lift together as they go up. So another type of door that we can do is we do have people asking us for a door, either horizontal sliding or vertical lifting with windows in it. This is something we did at the Pittsburgh Playhouse, where you can see the door on the left, and then you can see the opening. When the door is lifted up, you can see the windows up above the clear opening. Not quite sure why they needed that window there, but we could accomplish that and still maintain the STC rating that they wanted, which is in the low 50s. This is a vertical lift door we provided to the DuPage County College in the suburb of Illinois. This is at a Homeland Security SWAT training facility. And this is a gun range and training facility on a college campus. And it's set up with acoustic doors all around the perimeter. And so students can't hear gunfire going on in here. But what they discovered after they built the facility was that kids were, students were concerned because SUVs would pull up and they'd see SWAT members getting out in their gear, carrying guns. Well, that's not good on a college campus. So came back and they added this vertical lift door. You can see on the left that we did not have enough headroom, and we couldn't maintain the ballistic rating that they wanted by having telescoping. So what we did is we notched the door out and came up with a different method of lifting this door, from above, so that it would fit. This is a 8-foot wide by 8-foot high clear opening, and we only had about 14 feet up above. So that's why we had to do it this way. This is designed to NIJ level 4, which is equivalent to a UL level 8. Basically, it's 30-06 with a titanium armor-piercing projectile. So it's very high level of bullet resistance. So now they can drive the SUV in here, get out, unload the weapons, take the vehicle back out, and nobody's the wiser. We also can do bifolding doors. These can either be manually operated, or in a case like this, which is a pretty large one, because it's 14 feet by 14 feet, it's automated. We'll show you a quick video of this. All right, open her up. There you go. So again, is it just solving a different issue for someone? They didn't have room. After this door was installed, production equipment was put in that was quite close to these doors. So there was just no room for a swinging door. There was no room for a horizontal sliding door. There was no headroom for a vertical lift door. So the bifold door was able to accomplish what they wanted with the space that was allowed to us. Couldn't have the door swing in because they're actually moving large equipment in here that they do work on it. Actually, what they do in here is they use foam pellets to blow the oil and grease and paint off of engines so they can repair them. Just another bifold door. We did this at a theater. This was supplied for a theater in Joliet, Illinois. People will watch a little video about the theater or about the museum. And when it's done, they're kind of their ta-da moment. The screen lifts up into the ceiling, the door opens, and now you walk into the museum. It's just an unusual application for a sliding door. Again, didn't have room for a sliding door, but they did want it to be automated. This is a more typical sliding door that we see at a high school or a college type of facility. We also can work with roll-up doors. Now, we don't build this, but we partnered with someone who provides this door to us. Can either be solid or can have the windows in it. And we do some acoustic treatment to this to increase the acoustic rating of it. And in the right kind of application, it's a very good door. This happens to be a dyno test cell for Mack trucks, where they'll take an entire vehicle in there and test it under load. Did the same thing, different kind of door for Caterpillar, or I'm sorry, for Chrysler. So we see a lot of industrial type enclosures where we'll use this type of roll-up door. All right, so again, the reason I started this presentation with the photos is we do so many different types of door designs and applications. I'd like to say that they're all the same, but they just aren't. What is common is some of the basic features that I'm going to review with you right now. And then we just adapt our standard system to solve the particular project we're looking at. So the typical horizontal sliding door consists of a guide rail and block system to move the door. This is as opposed to the old method where we use track and trolleys. This feature provides a very quiet operation. Instead of a chain drive, we use a urethane belt drive mechanism. And then that's coupled with the motor and miscellaneous gears and parts and so forth that make the drive belt run. We also provide laser motion detection devices for safety. I'll get into that briefly, or in a minute. The components above all ship fully assembled onto a support angle. Depending on the size of the opening, there might be 2 support angles, but we pre-mount all that at the factory. We pre-mount the motor, the drive mechanism, the urethane belt, and we actually cycle test that in our factory before we ship it. So we know that the control panel works, we know the whole system is operating smoothly. So the door system then is completed by providing the door slab or slabs and a control panel. Every door, now we're talking horizontal sliding, has a beauty shroud over the support angle, the guide rail, and the drive mechanism. On the vertical lift doors, we use a different type of lifting mechanism there that we just won't get into right now, but there's a beauty shroud over the 2 towers that are lifting the door. On a horizontal sliding door, we have a leading edge pocket that the door goes into to create the acoustic seal. Of course, we've got the motor and the control panel. The motor horsepower is going to vary with the door weight. And we provide a 2-position operation controller. So we have open close as the function, and there's one of these is provided for both sides of the opening. So this is just a typical drawing of the shroud here on the left side. What you see is a shroud that is concealing, hence the term beauty shroud. It conceals the track and the trolley up here, the guide rail, I should say, not the track, the guide rail, the belt drive system. It also keeps it clean so that it doesn't pick up dust from the environment, and acoustic seals. When we're talking about a leading edge pocket, this is just one way we do it. There's many different variations of this. It just depends on the size of the door and the site conditions. And then we also provide a trailing edge pocket and sometimes a guide wheel down at the floor, which is what you're seeing here in the right diagram on the right side on the lower half of the page. This is just to show you typical. Hey, these change a lot, but it's the concept that we continue to use for acoustics. I want to talk about safety. We use the safety laser motion detector system for both sides of the door, and we use this in lieu of a safety reversing edge or a photoelectric eye. Now, this laser is field adjustable for coverage areas and fixed obstructions. And this is very important. If the door is stopped by the laser motion detection system, the door open or close button must be pushed to continue the door operation. That is, once the obstruction is cleared, the door doesn't know it. May or may not happen, right? So the door will not continue its operation until someone physically pushes that open or close button. That's a very important safety feature. I want to talk a little bit about photoelectric eye and safety reversing edges. The reason we don't use those is they're slow to react and they can be very dangerous. Photoelectric eye is like you have it if you have a garage door. That's an automatic garage door. As the door is lifting or closing, if you walk underneath the door, that photoelectric eye is the signal is going to get broken and the door is going to stop. The reason that doesn't work in these type of applications is somebody could be going through one of these doors with a forklift or a boom truck, and before the wheels get to that electric eye, you end up with part of the forklift or the load is already through the opening, and the door could come down and hit that. And someone has said, well, why didn't we just put multiple photoelectrics up the length of the door or the height of the door? You just don't know if those are always going to operate. It's too much to try to coordinate. this laser system, it works so well and it's so safe. I'll show you more details in a minute, that it just negates the use of the photoelectric eye. Regarding a safety reversing edge, again, on your garage door, there's probably a safety reversing edge built down into the bottom. If you're standing in that opening and that thing bumps you, the door is going to stop. Problem with our doors is they're so heavy, and somebody could perhaps have just an arm in the opening. With the safe reversing edge, there's just enough of a delay in that signal going to the controller to stop it that you really could have a very dangerous situation. So we do not and we will not use photoelectric eye and safe reversing edges. They're slow to react and very dangerous. And if there was a client out there that insisted we had to use that, then we would just decline to get involved in the job. But I don't think they would when they see how well this system works. This is what makes this safety laser motion detection system so good. You see the red curtain area, that can be adjusted in the field to whatever dimension the client wants it to be. If they have fixed obstructions that are near the door, this thing can be programmed to recognize that, so that doesn't trigger the door operation. So it's just a very safe operation for to stop the door if anything breaks that safety curtain. And this just shows where we mount it. So here's the diagram you saw earlier with the shroud. So we put one on the one side of the door and another one on the other side of the door. If the opening's wide enough, we'll use 4 of them, 2 on either end of the door, and it creates a very safe operation of the door. So standard features of the doors then, getting back into it, they all can have a storage pocket. This is optional based on the sound reduction requirement and on safety. We've done some of these at, like we did one at a student union at Loyola University in Chicago, and students could put their backpack or lean up against the wall when the door is closed, and then as it goes to open, it's going to hit them. Okay? It won't hit them because of the laser detection system, but that interferes with the operation of the door. So in an application like that, we'll build a false wall and actually make this like a pocket door. It's easy to remove it so people can get into it for service if necessary. But when we talk about a storage pocket, we're just talking a little false wall for the door to hide behind. In some applications, we provide a pneumatic seal system. This gives us better acoustic performance. We provide counterweights. Vertical lift doors will always have counterweights, but horizontal sliding typically do not need it unless it's going to be manually operated. Depending on the size of the door, we can put a personnel door within the door slab. So if you've got a theater application, there's just not enough wall space to have personnel doors, we can build a sliding door and put a personnel door in the slab. The one thing we cannot do with these is provide a fire rating. If an opening has to be fire rated and acoustical, then we're going to need the acoustic door, which we'll provide, and we have to provide a fire shutter. And either we can take that on as part of our turnkey capability, or the contractor can purchase that independently. But we can fire rate the panels, but we can't fire rate the system. So we just do not have a fire rating available on these sliding doors. So any acoustic consultants that are listening to this presentation, please bear with me shortly here, or for a few seconds. I've had some people ask me when we refer to STC and NIC, what is this? So this is just a layman's background information to help people understand this. An STC is just a single number rating of airborne sound transmission loss used to determine sound control between adjacent closed rooms. It can be used to rate floors, ceilings, walls, windows, and doors, such as sliding doors. It's a test done in an accredited sound lab in a controlled environment, and often is used as the basis for a specification. Generally speaking, the higher the STC rating, the more efficient, that is, the better sound reduction the construction is overall. It is critical to look at the transmission loss detail by active bands, but now we're getting into more detail than some people need. But I just want people to understand that when we talk about STC, it's a lab rating, and it's a means of measuring the performance of an object, in this case, the door. Now, what we prefer to see is a field guarantee, and that would be in the form of an NIC rating, or noise isolation class. Now, again, for the layman in the audience, this is a test done in the field after the noise control product or products have been installed. The NIC is a single number noise reduction rating of a partition, or in our case, the door. It could be of the room or the enclosure. This is just a measurement of how much sound has been reduced. Generally speaking, the higher the NIC rating, the better the sound reduction. So a door can be specified as needing an STC 50, or it could be specified as needing an NIC of 50. We would always prefer to see field performance on these because it's difficult to get a lab test. So this is the lab test that we do have. We have a lab STC 51 on these doors. This was done at Riverbank Labs many, many years ago. So it's an STC 51. We probably are not ever going to be able to get any additional lab tests because the test sample must be small to meet the lab test fixturing. So it's not really indicative of what we'd be providing out in the field, because these doors typically are 10 by 10 up to 50 feet by 24 feet, right? We can't test anything that large in the lab. The labs don't want us to attach anything to their wall, such as the support angle we need for the guide rail. It also is very expensive to provide a test on a one-off project. It's just not practical to lab test all these doors. You look at that variety of designs that we showed you, it'd be very difficult to test all those. But what we can do is we can advise consultants and architects of the anticipated field results we're going to get based on slab tests of the door slab itself that we've conducted previously. We also do some testing in our shop. These are just not sound tests of moving doors. To date, this hasn't been an issue. And I think the reason is we will guarantee the field NIC performance, and we can do that depending on the design of the door up into the mid-50s. So would love to be able to get an STC test on all these, but they're just too big, they're too unusual, it'd be too expensive to do for these typically one-off designs. So we've got a lot of experience and knowledge about what we can do to put these doors together to work acoustically, and with that, we'll guarantee a field performance. Now, we've supplied these doors from anywhere from 4 inches to 8 inches thick. The thickness is a function of the desired acoustic performance and the door slab size. It also wind load, for exterior applications come into play. So we designed the door thickness based on what criteria we're trying to meet. Generally speaking, with a 4-inch slab, we can get an STC of 45 to 54. 5-inch slab, we can get up to an STC 55 to 60. 6-inch and thicker, we get an STC 61 to 65. The thicker the door, now though, it becomes more problematic with the seals. There, we'd probably be using pneumatic seals. Our standard, though, is a 51. So we want people to consult our factory before they specify, or before anybody in sales quotes an STC rating any higher than 51. Doesn't mean we can't do it, but we just want to talk about the project and what the design is going to entail before we bid on it. As a standard, we prime paint these doors. The door slabs can be powder painted depending on size. In terms of clear opening, I think you see we're not really limited. We've supplied 50 feet wide by 24 foot high. We've supplied large biparting sliding doors. It all depends on how we build the slabs and then attach them to the guide block and guide rail. All these doors include adjustable mortise Teflon covered bottom compression seal. These doors are designed such that the bottom seal can be replaced without taking the entire door down. We can make them flusher with windows, and sliding doors, we want to have thresholds, which we provide, and those can be aluminum, nylon, or steel. On the electrical, we used to have different size motors given the weight, but we've now been able to standardize on a 1.5 horsepower motor for doors up to 5,200 pounds. And again, we're going to have to calculate that weight depending on the thickness of the door slab and what gauge metals we use. When we start getting into heavier doors, then we might go up as high as a 5 horsepower motor. And we, of course, supply that. As mentioned earlier, all motorized doors are furnished with 2, one interior and one exterior, 2-button open close operation interfaces. If a battery backup is going to be required, or a lockout or keyed interruption, and that's written in the specifications, we can do that. We just need to know about it. So a typical control system is we use a NEMA 12 enclosure with a fusible disconnect. We can either do 220, 240 volt single phase or 208 to 30 volt 3-phase operation. That electric service is just dependent upon site conditions and the motor requirements. We need to consult with the factory before we specify. So we need to know what's available on site, and then we have to take into consideration the size of the door before we finalize the electrical. And again, the way we're going to do this is door operation should be open, close. We can do open, stop, close if necessary, but typically what people want is just a 2-button controller. We do set up 2 different ways though. We can put it designed such that the operator has to hold the button down the entire time the door opens or closes. That is, you now have eyes on the door opening. Or in some applications, it's okay to push the desired button to open or close. The door completes that operation automatically, and somebody doesn't need to witness it or watch it happening as it's for safety. This is a typical control panel. When we build the door and set up and test it, we have the control panel, which we build, all put together. Our Mike Dott does this. He does a great job with these things. And I couldn't tell you what everything is in here. Mike could. So if you want more information, reach out to Mike Dott at Noise Barriers. But the control panel goes out fully wired, and it's been tested. I received the following email from Richard Talaske before our heavy-duty door webinar probably 2 months ago. He said that his questions could be, are the quiet swing doors quiet in operation? Is there any panic hardware, latching noise, door closer noise? And then his point is he's working on the design of theaters and concert halls. Quiet operation of doors is important, as well as the TL performance, transmission loss performance. Well, I think these concerns are valid with sliding doors. So I thought I would put together a response to that. And that is, because we've gone to this guide rail and block system, it's a very precision machine tooled operation where we get this track from. We do this in lieu of track and trolleys, which are noisy. And we have this urethane belt drive instead of the chain drive system. Now this is very quiet. You really don't hear it opening at all. In addition, the entire drive mechanism is covered with a beauty shroud, and this provides additional noise isolation. So it's a very quiet operation. I want to talk about installation and safety. I unfortunately don't have any photographs of sliding doors going up. Reaching out to our installers to try to get some. But this will get 1 point across, and that is, this is for a heavy-duty door being lifted into place. We do the same thing with our sliding door. We provide lifting lugs across the top of the door slab so that a low like this or a forklift, some mechanical means can be used to lift the door slabs into place. Back in the day, the only thing that you could do is you wrap a strap around this thing and have to be very careful as you would lift that up. So to install our doors, they arrive with these removable lifting lugs. These allow you to just lift that door right into place. Now the guide rail and track, that whole thing comes pre-installed. So that's either 1 or 2 angles. Again, it depends on the width of the opening. And that gets attached to the wall first, and then you hang the door slabs. And all of our oversized doors, both swing and sliding, have a mortise bottom compression seal. And you can get to that through a little removable plate at the bottom of the door. So should the seal ever wear out, it's easy to get access to that and change that Teflon-coated neoprene seal without taking the whole door slab down. Until noise barriers came up with this, other door manufacturers, what you have to do is you got to take the whole door down. Not only is it a lot more work, but it's just a little more dangerous. So regarding that control panel, every quote we send out, every transmittal we send out, we include this data sheet. And what this shows is who is responsible for what electric. Anything in blue, we furnish. Now, this will be custom done for every project, but we provide what's in blue. The general contractor or the owner provides what's in yellow or gold. The reason we do this is we want this set up so that power is brought to our control panel by someone else, by the electrician. You know, by code, it should be the electrician. But we don't want them going into our control panel at all. In fact, if they go into our control panel, it voids the warranty, because we've had people go in there and start messing around with things that we have already set up for the operation of the door, and they can really screw it up, and then we have to come back and fix it. So we're doing this so that nobody has to go into our control panel at all, and we clearly delineate who does what. This is a typical mechanical layout that we can provide to an architect in AutoCAD or PDF form, so they can drop it into a drawing. This is just a drawing that we provide to our installation group, so they can go out and get a rough opening, or to a GC to get us a rough opening. This is another data sheet we provide. We want to know that there's enough room to the left and to the right of the sliding door to where the control panel is. So how much headroom. So these are all the dimensions that we need to get to make sure that that site is going to be able to handle the door. So it just helps in the coordination that the architect needs between the GC and us. We always provide for every installation drawings, diagram of the shroud. And we do a typical electrical layout like this that gets takes that information that was on that previous page with the blue and the yellow. This will also be color coded, but this will actually show during the transmittals. This will show who is responsible for what electric. Then we provide a section looking through the door of the elevation and the plan view on the right, just to help everybody understand how this door is operating. We're working on one right now where nobody bothered to take a look at the wall curves. That we're working around that, but that's why this is here, so everybody understands how this door is going to interface with the building wall. So in summary, the advantage of the sliding doors by noise barriers is we do provide turnkey capabilities for the design, PE stamp, the supply of the door, and installation services. I think you can see from this presentation that we do have unlimited door designs and sizes to meet the most challenging architectural and acoustic performance requirements. We've developed a fast and we believe a very safe method of installing these doors, and that's important. We can provide powder paint finish, size permitting, in any standard RAL color. We also can custom match colors if necessary. And we provide the longest warranty in the industry with 5 years on material. Now, if you need any additional information about the QuietSlide or QuietLift doors, please reach out to marketing@noisebarriers.com. If you want to receive sample specifications, AutoCAD drawings, or budget pricing, please also reach out to marketing if you need any additional information on any Noise Barriers products, or if you've got a project that you're looking at right now and you want a sales rep to contact you, please reach out to marketing. And finally, if you have any constructive comments about today's presentation, good or bad, please share them with us so we can improve. I'm always changing these and adding things that people want, and I'm trying to make it as easy to follow as possible. So if you have anything that you'd like us to add, or things that you think are not necessary, please let us know. I'd be happy to incorporate that. So thank you. We know your time is very valuable. So we appreciate you attending this webinar concerning the QuietSlide horizontal and vertical lifting sound control doors by Noise Barriers. And that's the end of the presentation. So thank you all very much.